Number one, we're supposed to write a function with the following transformations. So the first thing I'm going to do is start with the setup. So y equals something, well, oh well, I'll make that my cosine. Okay, it's an amplitude of 2, so I'm going to put a 2 out front. There is a period of 8 pi. So my formula for period is 2 pi divided by b, or, just a reminder, b equals 2 pi divided by the period. So my period is 8 pi, that means 2 pi divided by 8 pi, that's 1/4. So we're going to put a 1/4 right here. Then I've got to the left pi over 2, so since I have it separated, or horizontal stretch or compression versus the shift, then I can just put plus pi over 2 because we're going left, and then up 6. So up 6 is going to be on the outside, plus 6. That's not my final answer, though. Final answer you need to distribute. So your final answer is y equals 2 cosine of 1/4 x. And then when I distribute that, I get plus pi over 8 plus 6. Now don't forget, you can test your own answer. If you're supposed to go to the left pi over 2, then do negative c over b. Negative pi over 8 divided by 1/4, same thing as multiplying by 4 over 1. You get negative 4 pi over 8, which is negative pi over 2, to the left pi over 2. So there's no reason to miss it if you can check yourself and determine whether or not you're correct, and then adjust if you need to. So there's number 1. Alright, number 2. I'm supposed to write a cotangent wave, so y equals cotangent, okay, with a vertical stretch by a factor of 6, so that means a 6 out front, a period of 3 pi over 2, I'll figure that out in a second, shifted to the right 5 pi, so that means it's going to be minus 5 pi on the interior. Reflected over the x-axis is actually a negative out front. There's no shift up or down, so I just got to figure out period. Now, period for tangent and cotangent is not 2 pi over b, it's pi over b, so that means b equals pi over the period. So b equals pi divided by the period, which is 3 pi over 2. Dividing by 3 pi over 2 simply means multiplying by 2 over 3 pi. Please don't move the pi with the 2. Oh, you can't even see it. Please don't move the, make that 2 pi over 3. The pi is with the 3, so 2 over 3 pi. The pi's actually simplify each other out, so b is 2/3. So my final answer for this one is going to be y equals negative 6 cotangent of 2/3 x minus 10 pi over 3. And that's what you should get for number 2. Number 3, I've got a secant wave. So y equals secant x something. Okay. So I've got a vertical stretch by a factor of 10.5, so I'm going to put a 10.5 out front. A period of 18. I'll come back to that. Shifted to the left 3, so that means plus 3 and up 7. So up 7. And then let's figure out that period. So period is 2 pi divided by b, or b equals 2 pi divided by the period. So b equals 2 pi divided by the period, or b equals 2 pi divided by 18. 2 pi divided by 18 simplifies down to pi over 9. So this right here is going to be pi over 9. And the reason why this one has a pi and the others don't is because this one you want the pi to simplify out. So my answer is going to be y equals 10.5 secant of pi over 9x plus pi over 3 plus 7. And there we go. That's number 3. For number 4, I need a sine wave. With an amplitude of 4, so I'm going to put a 4 out front. I shifted to the left 5 pi over 16, so plus 5 pi over 16. Down 7 halves, so I'm going to put minus 7 halves out front. Reflected over the y-axis. Reflected over the y-axis means a negative on the interior, so I'm going to go ahead and put that negative, and then I'll, oh, you can't even see it. That's funny. Okay, sine wave with an amplitude of 4. So 4 out front. It shifted to the left, 5 pi over 16, so plus 5 pi over 16. Down 7 halves, so minus 7 halves on the outside. Reflected over the y-axis, so I put the negative right there. And now I'm going to figure out b using my period. So period is 2 pi divided by b, or b is 2 pi divided by the period. And the period is 5 pi over 8. So dividing by 5 pi over 8 is the same thing as multiplying by 8 over 5 pi. Pi simplify out, and I'm left with 16/5, so I would put a 16/5 right there. So my final answer is going to be for sine, I'm going to distribute my negative 16/5. So negative 16x over 5, or negative 16/5 x, minus, now the 16 simplify out, the 5 simplify out, so it's just minus pi, and then minus 7 halves. And that is what we should get for number 4. Alright, did that freak anybody out? Everything going out? Good. Okay, we're supposed to write a cosine wave that matches this graph. So, as far as like figuring out period and all that, there's a couple different ways to do that. You can think about here's a minimum and here's a maximum. So I know in a cosine wave, a negative cosine wave, that's half of my wave. Or you could think from any point to its repeated point, like there's the entire period. So I can see from negative 2 pi to 2 pi, I've got an entire wave, if you want to think of that as a cosine wave from starting here. So either way, I know that period is 4 pi. My midline, it looks like it's at 2. So it looks like it's up 2. And then it looks like I'm going up 1.5 and down 1.5. So far, I know that I've got y equals cosine. And I know I'm going to go up 2. I've got an amplitude of 1.5, so I'm going to put 3 halves up front. Okay, period is 2 pi divided by b. So b equals 2 pi divided by my period, which is 4 pi. So b equals 1/2. So I'm going to put a 1/2 right there. And then I just got to figure out what kind of shift I have. So there's a couple different ways to do this, guys. My normal cosine wave with a period of 4 pi would look like this. I've got a cosine wave that starts up here, does this, and does that, right? With this being 4 pi. With this being 2 pi. So if I were to sketch a regular cosine wave with a period of 4 pi, then it would start up here. It would have a minimum at 2 pi, so minimum here, and then it would cross halfway through at pi. So this would be the normal cosine wave. So you have 2 options. Actually, you have 3 options. You could either just say no phase shift with a reflection over the x, right? So we could say one of my options is y equals negative 3 halves cosine of 1/2 x plus 2 with no phase shift. Y'all with me on that? Another option, though, would be to say, okay, if I just take my cosine wave and move it to the right 2 pi or to the left 2 pi. So right here we could put plus 2 pi or we could put minus 2 pi without a reflection, and those would also work. So if you take your regular cosine wave, move it to the right 2 pi or move it to the left 2 pi, or flip it, you've got all 3 of those options, so I'll go ahead and write down all 3. So we could have 3 halves cosine of 1/2 x. If I put plus 2 pi right here, if I move to the left 2 pi, then that would be plus pi plus 2. Or we could have y equals 3 halves cosine of 1/2 x minus pi plus 2. So that's if I went to the right 2 pi, then it would be minus 2 pi. So this is going to the right 2 pi, and this is going to the left 2 pi. Either way, these are all correct. Alright? Do you have to give me 3 options on your test? Just red. The rest of you can give me 1. Okay? Alright. Number 6. Let's look at number 6. So, these tick marks are kind of rude. Let's figure it out. I don't know if it's going to focus. There we go. Okay. So, I'm going to go ahead and just pick some points that I can see. It doesn't look like there's a shift up or down on this one. It looks like it's pretty well centered at the x-axis, so I think that's the center point. I'm going to try and figure out what that distance is between those 2 points, because that's, I know that's a distance of a wave if it takes from point to repeating point. And then I'll figure out where the vertical asymptotes if I need to. So if this is 1/12, then this tick mark right here is what? Wait, guys, what is that tick mark? 1/24 pi, right? So if every half tick mark is a 24th, then this is 1/24, 2/24. This right here, is it 3/24 or pi over 8? Yeah? So that's 1, 2, 3, 4, 5, 6, 7 24 right here, 7 pi over 24. So if I look at the distance between them, 7 24 minus 3 24 is 4 24. Yeah, so if I'm trying to figure out period, distance from one to the other. 7 24 minus 3 24 is 4 24, and that is 1/6. So that means my period is pi divided by 6, because that's the distance from point to repeating point. Okay, I think we could safely say that the first vertical asymptote is right here at pi over 24, and that this one right here is the next one, which is halfway between those. So if that's 1/24, 2/24, 3/24, 4/24, 5/24. So it looks like that's at 5/24. Which again, I can see the distance between them is 4/24, which is 1/6. Okay, so what I'm going to do is I'm going to think about a tangent wave with a period of pi over 6. I'm going to explore that down below. So, or out to the side. Let's do that. So normally if I have a tangent wave with a period of pi over 6, then I would split it in half, which would mean this is pi over 12, and this is negative pi over 12. Are y'all with me on that? If your period is pi over 6, you split it halfway between, and then it would look like this. Well, the fact that it's starting from above and going down means I'm probably going to have a reflection over the x-axis. So the fact that it does this means I'm going to reflect over the x, so that's going to have a negative out front. So I'm going to look at this wave right here. My first vertical asymptote looks like it is at, so like this vertical asymptote right here, I could either move it to the right, or I could think of it as this one right here. So I think I'm going to look at it as this right here. It was at pi over 12, and now it's at pi over 24, which leads me to believe that I moved to the left 1/24 pi. How do I feel about that? As far as figuring it out, there's a couple different ways to do that, but to me it's easiest just to see. My first vertical asymptote was at pi over 12, and now I can just look at it and say my first vertical asymptote was at pi over 24, which meant I moved to the left 1/24 pi. The other option is I could say, well, my first vertical asymptote was at pi over 12, and now it's at 5 pi over 24, which means we moved it to the right 1, 2, 3 24ths. If you'll ever notice that these two, when the amount that you move to the left and the amount that you move to the right should always add up to the period. 1/24 plus 3/24 is 4/24, which is the period. They should be the same. Okay, so I don't care which one I'm going to use. I'm going to go ahead and just pick the to the left 1/24 pi. Is that one a weird one for y'all? Okay. The only thing I can do is, the only thing I can suggest is playing around with it, graphing it out to the side, and exploring what it should be at, and then seeing where it is, and going from there. Y equals tangent x. Okay, so I did say we were going to have a negative because it's a flip. I'll figure out if there's a number out front in a second. It looks like Oh yeah, sorry. Thank you. So negative out front because of the flip. The period is pi over 6, so period is pi over b, or b equals pi over the period, which is pi over 6, or multiply by 6 over pi. So there should be a 6 right here. I'm going to go to the left, pi over 24, so plus pi over 24, or to the right, 3 pi over 24, whichever one you do. It doesn't look like there's an up or a down, and then I need to figure out if there's a number out front. Yeah, are you guys comfortable figuring out what the number out front is? What I always do is I find the distance halfway between my vertical asymptote and my center point, which is here, and then go up to meet the curve, or go down, and I can see that that is 3 up or 3 down, which means there's a 3 out front. Okay, so that would be y equals negative 3 tangent of 6x plus pi over 4. The other option is you could say minus 3 pi over 24, or pi over 8, I guess we could say. And so that would be, or y equals negative 3 tangent of 6x, let's see, that would be divided by 4, so minus 3 pi over 4. Cool? So either one of those would work for that.